All right. We're going to talk about two things today. One of them we're going to talk about now, and then I'm going to let you work on this paper a little bit more. And the other one we're going to talk about after you do that. So the first thing, to be able to measure with a protractor an angle like 6 radians. Hey guys. Hey guys. Connor. Okay. To be able to measure an angle like 6 radians using a protractor, what you need to do is you need to convert that 6 radians into degrees. So that's what we're going to work on first. Converting between degrees and radians. And it's really easy if you've done any other unit conversions ever, which you have. Second, we're going to measure sector area and arc length. And just in case you don't remember what these words mean from your geometry days a long, long time ago, a sector you can think about like a pizza slice. It's a slice out of a circle. And an arc you can think about like some pizza crust, cold, left over on a plate. So that's like one part of the outer rim of the circle, instead of an entire slice of a circle. So here we would find a length. It's a line. You find its length. And here you find the area of some shape. Okay? So that we'll talk about a little bit later. For now, let's convert between degrees and radians. And I'm guessing that most of you remember how to do a unit conversion. So let's go through one real quickly, just to double check. We're going to do this unit conversion the same way that you do any unit conversion, especially in, let's say, chemistry. Let's say, all right. So the speed of light, as most of you will remember, is fast. In fact, it's about 180,000 meters per second. So imagine 1 second, 1. Now imagine 180,000 meters. You can't because it's too big. So anyway, it's really fast. So what would that be like? 1,800 football fields plus the end zones, basically, lined up together. So that's pretty fast. Okay. I want you to convert that to miles per hour. To kilometers? I mean, couldn't you convert it to kilometers?
But I don't know how many kilometers are in a mile.
Okay. Hint. There are 1609 meters in 1 mile. It's true. Okay. So first, let's think about how to set this up. When I set these up, I'm I'm going to set up some train tracks. Okay. I've got 180,000 meters per second. So I've got tops of fractions that go along the top and bottoms of fractions that go along the bottom. Now it turns out here my unit is a fraction. So I can put the top of the unit on top, meters. And I can put the bottom of the unit on the bottom. That's just going to help me keep things lined up. Seconds. Okay, so let's start by converting from meters to miles. So I told you that there are 1,600 meters in 1 mile, but how do I set up that conversion? What should I put where? Somebody help me. Taylor Griswold.
Put 1 mile on the top and 1609 meters on the bottom.
All right, so why would I put miles on the top and meters on the bottom? How do you know?
The units match up diagonally.
Right. So we want to cancel out the old unit, right? We want to cancel out the meters. So we want 1 on the top and 1 on the bottom. Once I do that, they cancel, and I'm left with my new unit miles on top. Now it's still going to be in miles per second, but I'm closer to what I want. And always, to make one of these fractions, I put 2 equal quantities, just measured in different units. So 1 mile is equal to 1,609 meters. That's the same distance, just written in 2 different units. So when I multiply, I'm multiplying by 1, essentially. Just a funny-looking 1. Okay, so I cancel out my meter units. Now I'm in miles per second. So the miles is good. That's what I wanted. I want to end up in miles per hour. I need to go from seconds to hours. So I could go, let's say, from seconds to minutes, right? If you don't remember how many seconds there are in an hour. Or you could do some quick math. But either way, let's go from seconds to minutes. So I know there are 60 seconds in 1 minute. But which is going to go on top? Which one's going to go on bottom? Somebody else help me. Camry. Yeah, you got to have seconds on top. That way it'll cancel out with seconds on bottom. And you've got to have minutes on the bottom because that's going to be your new unit. And we want our new unit on the bottom of the fraction because it's a fraction. Meters per second. Okay. So 60 seconds is the same as 1 minute. Our quantity on the top and the bottom always have to match here. That way we're not actually changing the value of the measurement. All right, so now we're in miles per minute. And that's how fast you measure talking speed, I think. Right? So now I want to change from minutes to hours because I said miles per hour. So I know there are some number of minutes in 1 hour. There are 60 minutes in 1 hour. I put the minutes on top. That way the minutes cancel out. And so my only unit left on the top of the fraction is hours. And my only unit left on the bottom of the fraction, sorry, no it's not, miles is left on the top. And on the bottom I have hours. So my answer is going to be in miles per hour. Now all I need to do is go through and multiply this stuff out. So recall, you multiply all the stuff on the top together. And you can use your calculator to do that. It's some big number. Then you multiply all the stuff on the bottom together. It's just going to be 1609. You don't need to use your calculator for that part. So what is this really big number on the top? 6.48 times 10 to the what? Okay, so a lot. And then you'll divide that by 1609 because that's the number from the bottom. And we'll get an approximation here. So divide whatever you get from multiplying on the top by whatever you get from multiplying on the bottom. And that'll be your answer in miles per hour. So what do you get, you people with calculators? It is a big number. Light is fast. Hey, we've got these yellow things. Most of you already have one on your desk. They're calculators. The school district paid like $120 a piece for them. Let's put them to use. Grab a calculator. Start typing in some numbers.
I have 402,734.62.
All right, let's see if we get some more of that same number. All right, a couple nods. Let me get one more.
I got it.
I don't believe you.
Well, sorry.
All right, so 402,000. What was the rest of it?
734.
734. Is there a decimal after that?
0.6178.
All right, so we'll just round it. That's close enough. Okay, so that's how you do a unit conversion. There's one you've probably done before in like physics, something like that. Now let's do a similar unit conversion, only a little bit simpler, where we deal with angles. Okay. So just like in the previous example, we had to know, for instance, that there is 1 mile in 1,609 meters. They're the same thing, right? So if we're going to convert between degrees and radians, we need some sort of equivalent quantities that we can turn into a fraction. So we need some sort of equivalence we can use. Remember, an equivalence is just two things that are equal to each other. Fancy word for a simple idea. So we need a quantity in degrees and a quantity in radians that are the same quantity. And we have an infinite amount of choices. Just give me one possible equivalence we could say.
90 degrees equals pi radians.
90 degrees is the same thing as how many radians? 9 degrees is, half a pi, right? Because a pi is actually how many degrees? Yes, it's 180 degrees. And when we're talking about the number pi, let's just say pi. 3.14 is an approximation, but it is not pi. What about a full circle? What's a full circle in degrees? What's a full circle in radians? Okay, so we could use any of these numbers. It doesn't really matter which equivalence we use because the top and the bottom would still be the same. Which one do you think would be the simplest equivalence to use? Why, Cameron?
One pi.
So it's equal to 1 pi instead of 2 pi or half of a pi? Yeah, so if we use this equivalence right here, it will be convenient because there will be less simplifying that you have to do at the end of the problem. So that's the only reason to use 180 and pi instead of any of these other possibilities. Okay, so let's try an angle conversion. It's really simple. I'll give these simple instructions. Convert. Okay. So what if I start off with, let's say, 100 degrees? Obviously, I want to convert that to what? To radians, because it's in degrees. Now, I'm going to put that on top of the train tracks. and I need to multiply it by a fraction, and I'm going to use this equivalence right here. So what would go on the bottom, degrees or radians? Degrees, that's right. And what would go on the top? Yeah. And usually you don't write radians on a radian measurement because it's a number. Remember, it's the number of radii that you wrap around the edge of the circle. But it can help you here, just visually, to write the unit off to the side when you're canceling. So, as an exact number, I end up with what? So I'm gonna let me write it like this first. So 100 pi, that's what I would get on the top. Then on the bottom, I would get 180. Okay, so if I want an exact answer, all I need to do is reduce this fraction, and I want to leave pi there, because pi is an exact number. I can't simplify pi. So can I reduce the 100 and the 180? Yep. What can I divide them both by? We can start with 10. That's easy. Just take off a 0. Okay, now it's 10 and 18. Can I reduce 10 and 18? To what? Yeah, divide them both by 2. So 10 divided by 2 is 5. 18 divided by 2 is 9. So what's my exact answer? It is exactly 5 pi over 9. Now we didn't ever count in ninths of pi, did we? But you could. We could have. We just didn't. Because it was deemed not that important. Okay, let's try one that works the other direction now. Let's say I start off with, let's do another one in ninths. 7 pi over 9, just for fun. Okay, so obviously I want to convert this measurement to what units? Yeah, it's in radians, so I want to convert it to degrees. And when I'm setting up the train tracks, because my original quantity is already a fraction, it's going to benefit me to put the top of the fraction on the top and the bottom of the fraction on the bottom. 7 pi over 9. That's just going to keep everything lined up, just like we did with the meters and seconds above. So this time, when I set up my equivalence ratio, what needs to go on top and what needs to go on bottom? Yeah, I need to have radians on bottom because I'm already in radians. And again, if you want to, you can just write rad next to this. That way you have the satisfying feeling of canceling it out like that when you set this up. So pi radians, and what goes on top? 180 degrees. So I've got my old unit on the bottom, my new unit on the top. Then I multiply them together, and I see what I get. Now, if I'm paying attention, which I always should be, ahead of time, before I actually multiply, say, 7 times 180, and I definitely don't want to type in pi in my calculator if I'm going to get an exact answer. So 7 times 180, I'm just going to write out what I have up there. I've got 7 times pi times 180, and on the bottom I have 9 times pi. So the more simplification I can do before I actually multiply stuff together, the easier I'm going to make my life. For instance, we can probably go ahead and cancel out these pi's, right? Pi on the top, pi on the bottom. Sorry, no more pi. Is there anything else that we could reduce before we grab our calculators? Yeah, we can reduce the 9 and the 180. Because they're both factors on the top and the bottom. So before I multiply the 7 by the 180, which is going to give me some big number that I might not know the factors of, I'm going to reduce 9 and 180, which are smaller numbers. So they can both be divided by what? By 9. So it's going to turn the 9 into a 1, and the 180 into a what? 20. So now I'll multiply together the stuff that I have left. So I've got 7 times 20 on top, which is 140. And I have 1 times 1 on the bottom. I have nothing on the bottom. So it's just 140 degrees. Okay. Questions there? Feel pretty good about this? Just another unit conversion. We've been doing them since middle school. I divided the 9 and the 180 both by 9. All right, let's try one more, because this is the kind that you're going to see on that paper that you have out there right now. Okay. Let's say you want to convert let me ask you this way. Different question. Well, same question, different words. About how many degrees is 1 radian? So 1 radian, not 1 pi. That's 180. We know that. But 1 radian. Remember, a radian is what? Yeah, the length of the radius wrapped around the circle. And that's an angle. That's 1 radian. Not 1 pi, but 1. So about how many degrees is 1 radian? How can we figure that out? What if we converted it to degrees? That would give us the amount in degrees, right? Okay, so let's convert 1 radian to degrees. So how would I set up my fraction this time? What would go on the bottom? Yeah, the radian amount, so that you can cancel those out. And what would go on the top? What's equal to pi radians? 180 degrees. Now, this time, your exact number is going to look kind of weird. What do you get on the top? What do you get on the bottom? So that's not a very satisfying answer. Also, I said about how many. So we can approximate here. So grab a calculator. Wait, real quick, in our heads, let's see if we can figure out what this should be close to. What's 180? So pi is a little bit more than 3, right? What's 180 divided by 3? 60? So it should be close to 60, right? Okay, so grab a calculator. Let's see what we come up with. 180 divided by pi. Remember, there's a pi button on your calculator. It's right above the caret on the far right. All right, I hear a couple of numbers. Well, the same number twice. What are we getting? How about to the nearest tenth? All right. 57.3 degrees. Pretty close to 60, like we expected. Okay. Cool. So what I want you to do then is to go back to keep working on this paper right here. And because you now know how to do these conversions, I want you to also do the instructions for, let's just say, the second set of instructions right here. These that I just highlighted in blue. Okay. So for y'all, I'm going to give you about 10 minutes to work on this, and then we'll go ahead and turn these in and move on to some easy stuff. So what I want you to do, just go through with whatever you have left. Just go through and try and use the protractor and mark these positions. And for now, don't worry about finishing up the rest of the trig problems. Okay, so I want you to go through, do these unit conversions. The one I pointed at is not a unit conversion, where it says 6 radians, 3 radians, 1 radian, 5 radians. Do those unit conversions. Try to use your protractor to measure those angles as well. Okay, and then in about 10 minutes, we'll go ahead and turn in what you have done, and it'll be okay.
So was it going to be 10 or 15? Right there. Yeah.
You will be talking to Sylvia, I think.
I know.
You guys are those down. Just go on over to the other side. Try and connect the dots.
What is it? 6.
Yes.